So the next question you ask, well, what is that stuff sitting on? It's got to sit on something. I mean, these braces are sitting on something, and the other end of this roof beam has to be sitting on something. Well, what is it sitting on? Well, in the case of the roof beam over here, this ridge beam, it's sitting on studs in a wall. Let me find that wall here. So this is the wall that exists to define the space above here. So on the inside of this house, you'd put sheetrock on this and sheetrock on the beam, and you wouldn't see any of this. It would just look like a big, tall, open space. But behind the sheetrock is the framing, which is the whole point of this class. So this pony wall, we'd call it, because it's a short wall. It's an abnormal wall. It's going to have these studs in here that are acting as a post that hold the end of this beam and take the load down to the next thing in the house that will hold it up. So that, in that case, is what's holding that. But for all these braces, you might ask what's happening. So let's look at the big beam first. So this big beam is holding, it's sitting on the end walls of the house, and you will notice there's a bunch of studs below that because we want solid wood. Whenever we start concentrating loads in a house, we want solid wood connections all the way down to the foundation. So this is a beam. It is a ceiling beam, if you want to call it that, but it's a horizontal beam. That's just what it is. It's a huge member. It can be made out of different things, but it is in this case holding a few things. It's holding the post, which is holding this end of the ridge beam, which is holding all these rafters. So that's where some concentrated loads are going to come in. They're going to sit on this. It's also holding the pony wall, right? The pony wall right there, it's holding that. Well, how much weight is that? Well, it's not very much weight, but it's going to have sheetrock all over it, so there's kind of some weight there. So it's going to hold all that. What else is it holding? Well, it's holding these beams because these beams are installed to hold up the ceiling on the other side of the house and all the roof braces. So these beams are holding pretty much everything else on the other side of the house. One end sits on the wall where there's lots of studs, solid wood all the way to the foundation. The other end is held by a hanger. We use a lot of hangers these days because they're very good ways, very quick ways to push one load off onto another member in a easy way to install and a way that's well hidden, doesn't require any weird stuff. So the hangers are these guys. They're usually metal. They'll have lots of holes in them for nailing or structural screws. We don't just use regular screws in these, just nails and whatever specified by the manufacturer. But these guys are going to be holding a ton of weight. In this example, this thing's probably holding like some 5 to 10,000 pounds. Something crazy is sitting right here in this hanger. So that's going to transfer the weight from this beam and the other beam into the bigger beam that's spanning and holding wall to wall. So this is how we would design this particular situation. The placement of these beams, well, the placement of the biggest one is pretty much set by the house. If the architect said, hey, by the way, the ceiling is going to go up right here into a big open vaulted ceiling, well, that beam's got to be there because that's defining the edge of the whole thing, and there's a bunch of weight right there. So there's going to be a beam there. The other ones are sort of arbitrary. They could move in this situation. They could move left to right a little bit, not super important. What's important is that they break up the span of these ceiling joists in here that I'll talk about, and that they are in a good place that all the roof braces can come down and sit on them without violating that 45-degree rule. So those are more beams, ceiling beams. In this case, you would probably call these kind of a flush mount ceiling beam because the bottom of the ceiling beam is actually the ceiling level. It sits on the wall, and it's in line with all these ceiling joists that I'll show here. Right here. These are the ceiling joists. These guys sit on the wall, and then they will hang on the beam with some metal hangers or whatever, however you'd like to install that, pressure block, whatever you like. And they're flush in line with the beam. If I go exactly horizontal, this is the ceiling joist. That is the top plate of the wall. So it's all right there in line with the bottom of the beam. So those are the ceiling joists. They hold all the sheetrock. They'll hold whatever else is up here. They'll hold insulation. If you have attic space in here, these will probably be larger, and they might be decking on top of it. It'll hold more weight. That's all stuff that we factor in when we design these beams and ceiling joists and things. But those are the ceiling joists. So coming down through the house, we got all these roof and ceiling loads into these beams. Well, the beams sit on effectively posts in the wall. And the walls, let's look at the front wall here. The walls are framed up like this. This might look familiar if you've seen house framing. In this case, we have a whole bunch of studs where the beams come down and sit so that we got solid wood all the way to the foundation. And then we also have openings framed in our wall so that we can put doors and windows and things. And when it's important that when you effectively displace studs, to give you an idea of the stud is this guy. I'll talk about the members of the wall here. These are the studs, full height studs, king studs, if you will. And they're doing the weight, they're doing the load bearing of this wall. Each stud is holding some weight. They're all tied together at the top with the top plates. Here's the double top plate. It's the guy that is on top that ties the walls together and overlaps. I'll show that in a second. And there's another plate on top below that one, the regular top plate. And those two accept all the weight from the ends of the rafters. The rafters are sitting on it, and then it's got beams sitting on it. And on the other walls on the sides, it's got all the ceiling joists sitting on these walls. So they're accepting weight. On this side, it's the rafters and the ceiling joists. They're putting weight on these walls. So all these studs, they're all individually doing the job of holding that weight up. Now, I say that, and that's important because when you displace the studs with openings in the wall, because you need to get in and out of the house, and you need openings in the wall and stuff like that, you have to carry that weight with something else. And what do we call that? Well, we call that a header. A header is a term for effectively a beam that's inside the wall framing. That's pretty much the distinction there. It's called a header if it's in the wall. It's called a beam if it's on the wall. These are up in the ceiling. These are beams. Headers are like this. Now, occasionally you'll see really big headers that are the size of beams. You can call them a beam if you want. It really doesn't matter. But when I'm designing, I'm referring to these in walls as headers. So that's the distinction for me, at least. Now, what they basically do is they will take the weight from this stud and this stud, and they will spread the weight out to the ends, where it'll be carried down with this jack stud and this jack stud. So that's what those will do. So that's how the load is being transferred through here. The rafters are coming down to the plates. The plates are putting weight on these little cripple studs, which is what those are called, little cripple studs. Those put weight on the header. The header puts weight on the jack studs. The jack studs go down to the bottom where they hit the foundation and put the weight into the foundation. The bottom of the window in this case is just the sill. It's not holding any weight. It's just serves as a place to attach wood. And there are other cripple studs below that just to fill in, add to nail things on for the outside, nail drywall on for the inside. That's what those are for. Not holding any weight in this case. So over the doorway, we got the same thing. We've got the top plates putting weight onto the cripple studs that are here, and those sit on the header, which is taking the weight out to the jack studs next to the door. In this case, there's only one because there's not tons of weight here, one on each side, and that weight goes down to the foundation. And those jack studs are connected to the full height studs next to them, which connect it all up to the wall plates and make everything all tied together. And at the very bottom of this whole thing is the bottom plate on a concrete foundation. This will be treated, but this is the guy that ties everything together down to the foundation. It will be anchored down with nails or anchor bolts or whatever you need. So that's the bottom plate. That is a wall assembly. Now in the corners, in this case, what we've got are, I will show right wall. You got all these full height studs down the wall. I didn't put any openings in here because no point in needing them. Don't need them to explain. You'll see here there's a notch up here. So the first top plate is there to frame all the studs together. And the second top plate is designed to overlap with the other walls. So in this case, we had the top plate from the front wall come in and sit on top of this wall. So this wall was framed at the full dimension of the width of the house. This one comes all the way out to the end of the foundation. That wall goes up like that. And the front wall is inside that and stops next to it. It will be nailed, the studs will be nailed together, and then at the top, this overlap will happen at the front wall double top plate. So that guy right there, that's attached to the front wall, and it overlaps onto this wall, and it gets nailed down so that these are all connected properly. So the corner, in this case, there's many ways to create corners. In this case, I threw a fairly standard one in here. You got a stud, and then you got some blocks to space out the studs and another stud. And that just gives enough nailing so that you can nail the end stud of this wall into that one. And on the inside of the house, you have wood sticking out. It's hard to see here. You got wood sticking out for the drywall to be nailed to. So that's an important corner method. So that's wall framing, and that pretty much covers the whole structural thing. Those are all the structural elements we're going to be talking about here. Our job is to take all the loads from the top of the structure, use all the wood members that are standard that we got, understand how they're supported, bring all the loads down, support them all in ways we know how to do, and take them all down to the foundation safely. That is what we're doing here. So that's all.